In this video, we're going to take a look at the builder design pattern. We're going to understand what the benefits are to the builder design pattern, when you might want to use it, and how you can actually implement it. At the end of this video, we're then going to see how we can implement the builder design pattern with just a single annotation using the Lombok library. So the builder design pattern is used for when we want to create complex objects. So a complex object is this, it could be this example here. So we have a company data object, which includes many different variables and possibly other kinds of objects as a property to this class. So for company data, we have many different values. So we have the ticker, which is the short version of the company name as used on the stock exchange. And then we have many different doubles and ints down below, which represent some of the company's financial data. So we have the opening price, the high and low price, the year high and the year low, and many others. The idea here is that we have an object that we need to create, and there are many different properties which we will need to instantiate when we create this object. So the first question you might have is, how do we go about creating an object with all of these variables? And the first way we could do that is by creating a constructor that instantiates all of these variables. And then whenever we need the company data, all of these variables can be instantiated straight away. So if we head over to the application class, we can use this constructor to create our instance. And I'm just going to use Apple as an example. And when we go to use the constructor, IntelliJ provides us with a prompt just above to help us understand what item we're adding into that constructor each time. So I've created an instance of Apple data for the company data, and we have a couple problems here. First, if I wanted to create an instance of the company data, whilst excluding one or two or maybe more of these values, I'd have to create a brand new constructor of company data. And I'd have to do the same every time I want to instantiate a different combination of these different properties for the company data class. And the second problem is that this constructor uses many different doubles. There are many different doubles placed throughout the very long constructor, which could possibly lead to further problems where the constructor is used incorrectly. For example, what if the year high and the year low were the wrong way round? Or what if the opening and the high were the wrong way round? We would have a company data instance that is instantiated incorrectly, and this very long constructor that accepts many different doubles is a possible hazard to this problem. So we could begin implementing the builder design pattern by creating a new class, and typically this class will be named by the class that we're building, followed by the word builder. So for our example, it will be company data builder. This class will contain all the same properties as the class that we're building. So I'm going to go into the company data and copy all of the properties. And the responsibility of the company data builder class will be to build an instance of the company data class itself. So I'm going to create a method called build, and it will be public. It will return the company data, and it's going to be called build. And the response from this build method will involve the company data constructor while passing in all of these variables from the top. So you may be wondering, how do we go from this position where we have this build method to returning a populated instance of our company data? And the way this is going to work is that we're going to create a new instance of our company data builder. We're then going to set the variables that we would like to set, and then once we have done all those settings, we call this build method that will create the company data instance using the values that we have set. So the first step I'm going to do is derive all of the setter methods for our properties. And for each of these setter methods, I'm going to modify it. So rather than returning void, it's going to return an instance of the company data builder. So now within our company data builder class, we have all of these different setter methods which will assign the values of the property that are identical to the company data class. Then once we've done all of the settings, we can then call the build method right at the bottom, which will return a new instance of our company data while using the constructor that applies all of the different variables from the company data class. So let's have a look in the application class how we can actually do this. So I'm going to create a new instance of company data, and rather than creating a new version of the company data, I'm going to create a new instance of the company data builder. And to improve the readability of our creation, I'm going to have a line break for each setter that I call. So I can call the set ticker method, and the set ticker will return an instance of our company data builder. And let's say I only want to instantiate the ticker for our instance of the company data. I can then call the .build method, which will return the company data instance itself. So it will call the constructor from the company data, passing in the ticker value of APPL, and all the other properties of our company data will be set as null or the equivalent from the primitive version. So I'm going to complete the company data builder for all the other properties. We can now see how the builder pattern can be used to create an instance of our company data class. And while you may look at this and think it's slightly more verbose than using just the single line constructor, it's certainly a lot more readable, and it's also a lot more structured. So when it comes to assigning the value for each of the properties of the company data class, we can exactly see what the year low will be, what the 5-day high will be, what the ticker will be, and so on. It's a lot more clear for us to see how this company data instance is being created in a more structured manner. So the last part of this video, I'm just going to look at how we can create the builder pattern without having to create this whole company data builder class itself. And the way we can do this is by using the Lombok plugin. So if you go to your pom.xml, and I have the Lombok dependency installed just here. And it's important within IntelliJ that you go into your plugins and ensure that Lombok is also installed. And what I can now do is head to my company data class. And if I go right to the top, I can add the annotation of builder, and that's taken from the Lombok package. And now if I head to the application class, I can create a company data instance using the builder pattern, but going directly to that company data class without having to write any further code other than that single annotation. So here we have the company data.builder method and then the .build function. And now I can assign the 5-day high whatever value I'd like. I can assign the ticker value, and so on, just how I have done above with the company data builder class. However, now we don't actually need this company data builder class, and all the benefits from the builder design pattern can be achieved from just this single annotation from Lombok. So that concludes this video on how we can use the builder design pattern and the benefits it provides us from a more structured way to create complex objects in a much more readable manner.